Modern vehicle development makes more and more demands on noise reduction, aerodynamics, safety, and design. Vehicle windows play an important role in this. In innovative vehicle concepts such as the Signum, the lines of the tailgate and the rear window are significant elements in the striking design. A sprayed-on PUR rim on the convex rear window ensures the necessary gap compensation between the frame profile and the window. Modern vehicle windows with only a narrow gap to the body, sprayed-on trim strips and flexible window seals contribute to the high-quality design, optimum noise reduction and the best possible figures for aerodynamics. Using conventional methods, these vehicle windows can no longer be removed without destroying them and seriously damaging the paintwork. However, repair costs, especially unnecessary paintwork repairs, have a major effect on a vehicle's attractiveness to customers and therefore on its ability to compete in the market. The innovative glass removal toolkit BO-46974 is the complete cost-reducing solution to non-destructive removal of all Opel vehicle windows. The glass removal tools are available as a complete set in a case. The new glass removal toolkit enables glass to be removed safely and cleanly by just one mechanic and saves a considerable amount of time. In addition, the small number of vehicle parts which have to be removed, for example rear quarter windows, is a major time and cost-saving factor. The windows are cut out using a round, specially hardened cutting wire with a high degree of elasticity. When used correctly, no serious damage is caused to the body. This avoids expensive repairs, both in terms of time and money, and also means that the original corrosion protection of the Opel body parts is retained. No extraction is necessary when working with the glass removal tool. In contrast to thermal cutters, there's no environmental pollution caused by vapours. Windscreens are removed from inside the vehicle. Access to the windscreen is simple. This is particularly advantageous in vehicles with a high body. The advantages of the new glass removal toolkit are so convincing that Opel has harmonized the development of windows and glass roof modules for new vehicles to enable removal with this system and has optimized it even further. The glass removal toolkit BO-46974 consists of a complete set of various tools and accessories in a carrying case. It includes 2 winches, a ratchet with extensions, a wire hole tool, a wire insertion tool, guide needles, an installation spatula, a pinch weld scraper, protective shields made of plastic, safety glasses and safety gloves. A 3-kilogram roll of the round, specially hardened 0.75mm cutting wire is also included. The 3-kilogram roll is sufficient for removing approximately 100 windows. The cutting wire is classed as a consumable and can be reordered. One of the 2 winches is adjustable and can be modified with a second reel for removing glass from small windows, for example in the rear quarter panel. There's a separate toolkit for removing very small windows adjacent to the A pillar. Removing windscreens is explained here using the Signum as an example. The stages of the operation apply by analogy to all types of vehicle. Caution. To ensure that no stress cracks occur in the glass when removing it, the vehicle should be on a flat surface with the front wheels pointing forwards. Before starting to remove the glass, the battery is disconnected as a safety precaution. First of all, pull off the roof strip. Then, remove the wiper arms. Before removing the cover of the radiator tank, protect the corner from damage with adhesive tape. Only by removing the inner panelling at the A pillar is it possible to follow the movement of the wire when removing the glass and to check the window after it's been reinstalled. Finally, remove the interior mirror casing and release the contacts from windows which include rain sensors. Caution. Safety glasses and safety gloves must always be worn when removing vehicle windows. The length of cutting wire required for windscreens, rear panel and tailgate windows is determined from the diagonal of the window times 4. The wire is always taken from the tied roll. 1 coil of the cutting wire roll is equal to approximately 1 metre. The most suitable point for drawing the wire into the vehicle is the upper area of the A pillar opposite the driver's side. To avoid damaging the paintwork, mask the point where the wire insertion tool is pushed through with adhesive tape. The wire insertion tool is pushed from the inside outwards through the adhesive joint. Guide the 2 ends of the wire approximately 1.5 to 2 centimetres through the insertion tool, bend them over, and draw them into the interior as far as the centre of the steering wheel. Then, bend the ends of the wire to more than 90 degrees. This makes it easier to guide the wire into the winch. Starting at the insertion point, lay the wire anti-clockwise around the corners of the window and draw in under the edge of the window. Caution. At roof level, the wire is rolled in, applying pressure. To prevent the wire at roof level from slipping out again, it should be secured in the middle of the windscreen with adhesive tape. The surplus wire is drawn inwards. A long and a short end of wire are now present inside the vehicle. Commence rolling up the wire at the longer end. The glass is removed from the inside. Pull the seat forwards so that the whole windscreen can be reached easily. The first winch is positioned above the steering wheel next to the rearview mirror. The reel of the winch is turned towards the roof frame. To guarantee optimum adhesion of the suction pads on the glass, always keep the suction surface clean and dry. Clean, dry glass is also essential. Insert the longer end of the wire into the bore in the reel. Depending on how much space is available for rolling up the wire, the long or short extension can be inserted on the ratchet. The wire is initially tensioned with just a few turns. It's guided with the wire hole tool during this process in order to protect the interior fittings. Caution: before cutting, check that the wire on the roof and at the corners is under the windscreen. In the first stage, beginning at the starting point, the wire cuts the upper edge of the windscreen as far as the position of the winch. In right-hand drive vehicles, the stages of the operation are carried out the opposite way round. During cutting, always observe the path taken by the wire and guide it with the hole tool to protect the interior fittings. Once the cutting wire has reached the first winch, the second winch is attached. In the second work stage, cut along the A pillar from top to bottom, stopping just before the corner. The second winch is positioned in the lower corner. The short end of the cutting wire is inserted into the reel. The wire is placed in the guide channel of the winch and tensioned. Caution: always ensure that the wire is not inserted between the rubber suction pad and the guide channel. Once again, the wire is guided with the hole tool. If the stop point is reached just before the corner, the winch must be moved. However, before moving it, the wire hole tool and the ratchet must be removed. In the third work stage, cutting takes place around the corner and along the lower edge of the windscreen. When moving the winch, the suction pads are released and the black locking knob is drawn back and held. The wire is then no longer under tension and the winch can be moved with a slight turn and reattached. The wire is inserted in the guide channel again and the ratchet is placed in position. To avoid damage to the instrument panel, the plastic protective shield is placed between the wire and the instrument panel. When cutting around the corners of the windscreen, a little more force must generally be applied. Work slowly and carefully. Now, in the fourth work stage, the remainder of the lower edge of the windscreen is cut and around the corner to the middle of the A pillar. During cutting, the protective shield must be moved as the wire moves over the whole length, as far as the corner. When cutting the corner at the A-pillar, the wire hole tool is also used to guide the wire, and it too is moved along the A-pillar. So that the windscreen can be cut out completely in the fifth stage of the operation, the wires must cross one another. Release the first winch and move it downwards. Position the second winch in such a way that the wires cross. Now, with the second winch, cut round the corner. The windscreen can now be cut out completely. The method of non-destructive glass removal described here can be used to remove all windows without damaging the paintwork. Special factors in individual types of windows will be discussed in the subsequent sections. When preparing the Meriva tailgate window, the adhesive is penetrated with the wire insertion tool close to the lower corner and the wire is drawn inwards. To draw the wire under the edge of the window more easily, the tailgate is pushed down and the wire is laid around the window. The wire is drawn further inwards and tensioned slightly. Steel needles are pushed into the adhesive to guide the wire so that it can be drawn into the convex areas at the sides. To prevent the window from slipping down, attach strips of adhesive tape which help to fix the wire at the same time. Cutting out the Meriva tailgate window is also done using the method described in Section 1. The cutting process is shown here as a complete procedure, being carried out by just one mechanic. First, the lower edge of the window is cut up to a point just before the wiper motor. Using the second winch, the right-hand edge of the window, including the upper corner, is now cut. Special factors, such as cutting, for example, where there are heating conductor contacts and a sprayed-on PUR rim, are described in the subsequent sections. The upper edge of the window can be cut by moving the winch. Both winches have to be moved to cut round the next corner. The penultimate work stage consists of cutting out the lower left-hand corner. Since the convex curve of windows varies, the winches don't have to be in the exact position shown. If a winch should detach itself from the window because of the curvature, a better position must be found. After the wires have been crossed, cut around the wiper motor with both winches. Using the new glass removal tools, it's also possible to remove the window from the Astra G tailgate, despite the narrow gaps to the body, without damaging the trim strips and the flexible window seal. Before removing the window, attach adhesive tape to both sides of it to prevent it from slipping downwards. Approximately 5 centimetres above the heating conductor contacts, push in the wire insertion tool at an oblique angle. Thanks to the angled insertion tool, it's possible to insert the wire. The wire is inserted from below upwards, so that the tips of the wire turn against the trim strip whilst being drawn in, and thus don't damage the paintwork. The slight deformation of the plastic reverts to normal automatically because the strip is pre-tensioned. The wire is inserted in the joint and tensioned around the corner. Subsequently, the wire is rolled under the upper and lower flexible window seal. The Astra G tailgate window is cut out following the work stages shown here in the overview. The upper edge of the window is cut by moving the winch several times. To prevent the heating contact from being damaged, the small protective shield is inserted between the wire and the heating conductor. At the same time, the large protective shield protects the paintwork. In other words, the wire runs between the two shields. After cutting along the lower edge of the window, the non-destructive removal of the tailgate window is completed without damaging the paintwork. To remove the window from the Signum tailgate, it's usually possible to simply push the wire into the channel in the upper and lower trim strip. If this is not possible, the wire must be rolled under the trim strip. The most suitable place for drawing in the wire is to the side above the fastening for the gas compression spring. The two ends of the wire are slightly tensioned and drawn inwards through the adhesive using the wire insertion tool. Before the wire can be tightened completely around the window, it must be fixed with the guide needles at both convex curves of the window. The Signum tailgate window is cut out following the operation stages shown here in the overview. Cutting starts at the upper edge of the window. Just before reaching the convex curve at the corner of the window, the PUR rim layer is thicker in order to compensate for the gap between the window and the body. The wire must be guided by hand at this point in the cutting process so that it follows the optimum path in the middle of the bead of adhesive. On both sides, in the area of the high embossing in the frame, the wire is pressed against the window with the hole tool so that no damage is caused to the paintwork. If the wire is guided carefully and kept under observation, the worst thing might be a few relatively small scratches in the top coat, which however don't need to be repaired. Caution: never apply glass primer or combi products. These products do not provide corrosion protection. The window can be reused even with a partially cut-away PUR rim. When refitting the window, this must be compensated by applying more adhesive. When removing small windows, for example in the Meriva rear quarter panel, first set the adjustable winch to the shortest length and attach it. This winch is provided with a double coil for both ends of the wire. Removing the Meriva quarter panel window is possible without dismantling the interior panelling. Only the door seals need to be released. The most suitable point for pushing through the wire is the lower corner of the panel adjacent to the C-pillar, to which a strip of adhesive tape has previously been fixed. Use the wire insertion tool to draw the cutting wire into the interior of the vehicle. The wire is laid around the window at the top corner and under slight tension is placed along the C-pillar. To enable the wire to be rolled in more easily under the window, spray some washing up liquid diluted with water onto the flexible seal. Never use silicone or spray oils. These substances can penetrate the adhesive during cutting and result in loss of adhesion when the window is reinstalled. The quarter panel window is removed with the double reel in 2 stages. Caution: the inner panelling components obscure the view of the point at which the wire passes through the adhesive. Therefore, it can happen that the wires are in such a position that the lower wire is also drawn in when cutting commences. In this case, the wire must be relieved of tension again so that the 2 wires can be separated from each other. Using the small protective shield to protect the inner panelling, first cut along the C-pillar and around the upper corner. Use the different rounded areas of the small protective shield to provide the best possible protection for the inner panelling. In the next stage, the ratchet is changed over to the second reel and the lower part of the window is cut out. When cutting round the corners, either the wire hole tool or the protective shield can be used, depending on accessibility. Finally, cut along the D pillar until the wires cross. Small and medium-sized cracks in the window are no problem when working with the glass removal tools. The statics of the window are also sufficient for working in these situations too. You can proceed using the method described with no problems. Seriously damaged or smashed windows should be knocked out completely while observing the safety regulations and following the service instructions. The Opel Adhesive Systems product range is divided into a number of groups corresponding to different requirements. There are different adhesive systems for bonding metal to glass, bonding metal in the body sector, and for repairing plastics. All these systems have been tested and approved by Opel. New adhesive systems for bonding windows and repairing bodywork are much easier to handle and offer increased effectiveness. The new single-component window adhesive and the new corrosion protection adhesive and sealant system will be described in the following sections. The new single-component window adhesive, together with the new Combi primer, is an Opel tested and approved system for bonding windows. The single-component adhesive kit consists of a 300 milliliter adhesive cartridge, 2 pre-cut nozzles, a primer stick, a Combi pack with cleaning and drying cloths, and processing instructions. An important precondition for fitting windows is that the individual components are compatible with each other. Up to now, a primer, an activator, and a PUR rim activator were required for a wide range of applications. The new Combi primer is suitable for all the requirements of the base materials used at Opel GM. Original and repaired paintwork, glass ceramics, and PUR rim. Thus, the Combi primer is a highly reliable system. Using the new primer stick, application is precisely metered. It's quick and reliable. As opposed to previous methods of applying adhesives using awkward pieces of equipment, the single-component window adhesive is applied using standard commercial cartridge guns, which can be operated either manually, by battery, or by compressed air. It's no longer necessary to invest in special application equipment. The single-component adhesive is processed cold and saves time, as the vehicle can be driven only 2 hours after the adhesive has been applied. The passive safety of the vehicle after the repair corresponds to its original condition. Crash tests carried out just 2 hours after installation of the screen have impressively demonstrated this. The technically correct use of the single-component window adhesive guarantees fulfilment of the Opel GM specifications with regard to the warranty on body repairs. PU adhesives are flexible and co-load-bearing materials used to make a structural joint between the body and windows. Vehicle windows are a co-load-bearing component. The demands this places on design characteristics are met by the new highly modular single-component window adhesives, even in repairs. The adhesive bead is simple to apply and is highly stable. A new adhesive technology has produced a high level of crash safety without the adhesive having to be fully cured. In addition, the adhesive is non-conductive. In other words, it insulates, which prevents corrosion on a metallic base material. Repair trials with conductive adhesives and universal primer applied to areas of bright metal led within a short time to serious corrosion damage. In order to produce the best possible adhesive bond between the body and the window, a number of different accessories are needed: cleaning cloths and primer. The purpose of the cleaning cloth is to remove particles and the film of dirt in order to ensure a good bond between the adhesive and the window. The free-flowing primer smooths and therefore increases the size of the surfaces to be bonded. This improves mechanical adhesion. At the same time, the primer acts as a UV filter for the adhesive. After the primer has dried in the air for approximately 10 minutes, the adhesive can be applied. The chemically similar surface of the primer and adhesive produces optimum adhesion of the surfaces to be bonded. Shown here as an example is fitting the windscreen of the Signum using adhesive. The process applies by analogy to other types of vehicle. If a removed window is to be reused, the residual bead of adhesive on the glass and body can be cut back with the pinch weld scraper from the glass removal toolkit to a maximum residual height of 1 mm to prevent damage to the paintwork and to the ceramics of the glass. After cutting back the residual bead, the bodywork flange must be cleaned as described in the service instructions. Caution: do not apply primer to the residual bead. To prepare a new window, clean it with the cleaning cloths from the combi pack. Even on new windows, pre-treated with primer, the combi primer should again be applied. The combi primer must be applied evenly. Uneven application leads to reduced adhesion. It's essential to observe the air drying time of approximately 10 minutes, as otherwise the chemical reaction with the base material will not be sufficient. In the case of windows with a sprayed-on PUR rim, such as the tailgate window of the Signum, for example, the combi primer is applied in one process to the glass ceramics and to the PUR rim. Caution: when installing windows with heating conductors, there must be no contact between the adhesive and the collecting rail of the heating conductor. At this point, electrical transfers are possible, which can lead to corrosion damage to the body frame, even though the adhesives used in production and service consist of a PU material with low conductivity. Before applying the single-component window adhesive, 5 self-adhesive 4mm spacers, corresponding to the service instructions, are applied to the body within the adhesive bead. This guarantees the minimum distance between the window and the body. The single-component window adhesive is applied using standard commercial cartridge guns, which can be of the manual, battery, or compressed air type. The optimum adhesive bead is produced by the specially pre-cut nozzle from the adhesive kit. Precise placement of the adhesive bead is only possible on the body. Always start at the top in the centre of the body. The window seal is dependent on even application of the adhesive. Make sure that joints are clean and overlap the adhesive bead for a short distance. Without wasting any time, the windscreen is aligned with the roof frame and positioned evenly all round by pressing it gently into the bed of adhesive. Do not use tensioning belts to fix the windscreen. Adhesive tape is sufficient for this purpose. Caution: observe the 2-hour standing time. For Opel, body repairs are part of a complete system, starting with the design process, which makes high demands on crash safety and torsional rigidity, without increasing the vehicle weight. The use of structural adhesives in automotive construction enables the comfort, safety, and lifetime of vehicles to be increased significantly. Using structural adhesives in both manufacture and repair work has produced excellent results, which are comparable with conventional welding processes. Opel consistently applies the most up-to-date repair methods for maintenance. As early as the design phase, decisions are taken on repairs of vehicle sections jointly with the development departments on a step-by-step basis. With the new corrosion protection adhesive and sealant system, a body repair system is now available which has been tested and approved by Opel and offers a wide range of advantages in comparison with the current material. The new corrosion protection adhesive and sealant system consists of a 2-component adhesive cartridge, 3 static mixers, 100 milliliters of cleaning solution, 3 green cleaning cloths, 3 blue drying cloths, and the processing instructions. Investing in special application equipment is no longer necessary. In contrast to the previous application of 2-component adhesive, the new 2-component EP adhesive is applied with standard commercial cartridge guns operated manually with a battery or by compressed air. The cartridge has an internal container for the white component, the hardener. Mixing with the blue component, the resin, takes place in a 2-to-1 ratio in the screwed-on static mixer. The 2 components only react with each other in the mixer. If the cartridge has not been emptied completely, the mixer simply remains on the cartridge after use and is only replaced with a new one before being used again. This makes it possible to empty the cartridge completely and significantly increases the economic viability of the material. The increased handling time of the adhesive, of up to 120 minutes, now also permits time-intensive work such as, for example, repairs to the vehicle floor. Further areas of application are the laser-welded roof, parts of the front of the vehicle, and the outer rear quarter panel. Further advantages of using a body adhesive are good tolerance compensation and optimum corrosion protection in the flange area. The corrosion protection adhesive and sealant system has outstanding bonding characteristics on coated sheet metal repair components, high alloy steels, and pre-treated aluminium. Compatibility is guaranteed with the majority of sealants and sealing materials, and with overpainting using conventional paint systems found in the repair sector. The system fulfills the high demands made on passive safety. The body structure is only guaranteed again after a repair if the corrosion protection adhesive and sealant system is used and the service instructions implemented precisely. The excellent corrosion protection characteristics fulfill the Opel GM specifications for the warranty on the body repair. The advantages of the increased handling time for the new two-component adhesive system are demonstrated using the example of repairing the rear floor and the lower rear panel with undamaged rear quarter panels. After inserting the cartridge, the two components are squeezed out until they reach the same level. Only then is the mixer screwed on, having been pre-cut to a 6mm discharge aperture. The adhesive is only applied to one side of the new component, the lower rear panel reinforcement, prepared in accordance with the service instructions because the assembly area contains multi-layer plates. The reinforcement for the lower rear panel is now pushed into the insert corner for the rear light and inner rear quarter panel, but is not yet fixed. A further bead of adhesive is applied to the joint between the lower rear panel and the floor of the luggage compartment. To ensure that the floor can be inserted cleanly, the adhesive is only applied to all the contact points of the inner rear quarter panel, the wheel housing, and the rear frame longitudinal member with strut. After the areas of the floor which have been ground bright have been coated with adhesive, the floor is placed in the body. Only when the last bead of adhesive has been applied to the overlapping flange on the body floor can the floor finally be inserted. The new part must be mounted so that it overlaps under the remaining floor in the floor overlap area. Work must continue quickly after applying the adhesive. The repair operation must be completed within 2 hours. After attaching the fixing rivets and resistance spot welding, as specified in the service instructions, the surplus adhesive is spread with a flat paintbrush to provide a seam seal and corrosion protection. The repair is completed by fitting the outer rear panel. Innovative and successful vehicle concepts require new technologies, not only in design and production, but also particularly in maintenance. An important objective is to encourage customer loyalty by implementing the highest possible quality standards and cost-effective repair methods. Opel is facing the challenge and developing state-of-the-art media to allow new techniques to be put into practice.